All right, guys, this is your review for the Carnegie checkpoint assessment or test. I'm going to do the evens. You need to do the odds. They should match up, so the evens should help you do the odds. Number 2, what is the equation of a line that is perpendicular to the line graph below and it passes through the point negative 3, 2? So first I'm going to graph the point negative 3, 2. And then the next thing I'm going to do is figure out the slope of the original line. So pick 2 points, and then you're going to figure out the rise, which is 1, and the run, which is also 1. And I'm sorry, the rise went down, so that's negative 1. So the slope is negative 1 over 1. So we want the perpendicular slope. So we're going to have to flip and change the sign. Okay, and then using this point here, we're going to use this slope. So starting from that point, we're going to use that slope. So rise 1, run 1, rise 1, run 1. And that'll give us additional points. And there you go. The equation of this line, which is what we need, we're going to use y equals mx plus b, or you could use point slope form, but we have a graph, so we could just do it this way. The slope we know is 1 over 1, x, and then the b is just the y-intercept, which is right here. So that's 1, 2, 3, 4, 5, positive 5. So I'm going to rewrite that as 1x, x plus 5. 1 over 1 is the same thing as 1, and 1x is just the same thing as x. So there you go. Go ahead and try number 1. Keep in mind that number 1 says parallel. Number 4, determine the equation of a horizontal line. Horizontal line. So that means we're going to use HOI. H is horizontal. The O just is for 0. And then Y is for the equation y equals whatever number. So since we're using HOI, that tells us that our equation should be y equals a number. So just come over here to the coordinates, which are 1, 6. And this is our y coordinate. So it's x, that's the y. So plug in the 6 there, and that's it. Try number 3. Number 5. Just getting number 6. What is the equation of a line parallel to y equals 3/4 x plus 2? That passes through 4, 5. So parallel slopes are equal, don't forget. So the slope in this case is 3/4. And the point is 4, 5, which means, well, we can use point slope form. So y minus y1 equals m times x minus x1. And we're going to substitute. This is x1, this is y1. So I'm going to substitute for y1, m, and x1. y1 is 5, m is 3/4, and x1 is 4. So again, the slope was 3/4 because it needs to be equal to the original one since they're parallel. You could leave the answer like this. This answer is in point slope form. I'm going to go ahead and change it to slope intercept form, but you could leave it like that. To change it to slope intercept form or y equals form, we're going to distribute the 3/4. So that will give us y minus 5 equals 3/4 x. And then 3/4 times 4 is just 3, so that's minus 3. And then to get y by itself, we're going to add 5 to both sides. So that's going to be y equals 3/4 x. Negative 3 plus 5 is positive 2. And this would be the equation in slope-intercept form. All right, try number 5. Number 8, determine the equation of a vertical line. Vertical line. So right away my feelers are going off there. And it says equation, so we're going to use VUX. V is for vertical. U is for undefined. And then X is for the equation of vertical lines, which would be X equals whatever number it is. All right, so since we're using X equals, we want to use the X coordinate, which is, I'm just rewriting it because it's hard to read like this, is 6. So that's X equals 6. And we're done. Try number 7. Number 10. What is the equation of a line perpendicular? So perpendicular slopes are negative reciprocals, which means you need to flip and change. So let's start by identifying the slope, which is negative 2/3, and we're going to flip it and change the sign. So it's going to become positive 3/2. And this would be our x1, that would be our y1. Again, we have a point and we have a slope, so we're going to use point slope form. I'm going to substitute for the y1, the m, and the x1. Y1 is negative 3, m is 3/2, and x1 is 3. Don't forget, add a line, change the sign, because we have that double negative. We could leave it like this in point slope form, but we're going to change it to slope intercept form instead. To get y by itself, we need to distribute the 3/2. That's going to leave us with y plus 3 equals 3/2x. And 3/2 times 3 is 9/2. That's a fraction, obviously. And I know that makes us uncomfortable, but you're going to have to deal with it. And in fact, I'm going to change it to a decimal because I got to subtract 3. So 9/2 is 4.5. I know this is weird. I got a fraction and a decimal in the same equation, but you're going to be fine. So we're going to subtract 3 from both sides like this to get y by itself. So that's going to be y equals 3/2x minus 7.5. It looks crazy, but it's all good. Go ahead and try number 9. All right, number 12. I'm actually going to do number 11 because it has the answer choices. So I kind of switched it up here. The figure shown was constructed using rigid motions, starting with line segments constructed in one or more squares. Describe a sequence of transformations of a figure that would produce the resulting shape. So just real quick, rigid motions are these: translation, reflection, rotation. So we're going to use those. All right, sequence of transformations. AB. Okay, so that means we're starting with AB. All right, and we're going to do something about point B. When in math, when we say about a point, we mean around a point. So that's rotation. We're going to rotate about point B. If we're rotating about point B and we're trying to make a square, we got to go this way. and that's going to be 90 degrees. So I can cross out the 180s. And this direction going to the right like this, that is counterclockwise. Because think about like a clock. If you're going to go all the way around, that's the opposite direction a clock should go. So it's counterclockwise. I'm just going to put CCW for counterclockwise. Then, after we do that, this one's going to now be formed. And we could reflect across this line. So that would be reflect. Okay, and we're reflecting across that yellow line. The equation of the yellow line, let's see, it's horizontal, so that's hoi. So that means it's going to be y equals, and that's the 4, so y equals 4. All right, so use that to help you try number 12. Number 14. Use the line segment shown to construct EF with a length equal to AB plus 2CD, excuse me. All right, basically that just means we're going to take this and then we're going to take this twice, put them together, and it's going to create a longer line. All right, I don't have a compass that I can show you here, so I'm going to do this with circles instead. It's going to get interesting, but just stay with me. First thing I'm going to do, draw a line segment with an endpoint. Okay, and that's supposed to be E for EF. Then, I'm going to change this to gray. I'm going to make an arc, or I'm going to get the distance from A to B is what I'm doing. By using an arc. Now, I got to use circles because I'm using this app, so it's all good. All right, so it said we have to do AB. So we got AB, and then we need twice the length of CD. So I'm going to do the same thing for CD. Struggles. Just struggles. All right, so I make sure that I center it around CD. And boom. Oh, no. Don't get too excited. And it said twice, so I have to do it again. Oh, man, I didn't make my line long enough. Hold on, y'all. Let me extend the line, child. All right, great. All right, so I'm going to erase like this so y'all can see how it would look if I was using a compass. So when we use the compass, we do arcs, and an arc is just a piece of a circle. I'm doing a whole circle because I'm using notability, obviously. But yeah, so that's it. This is the answer. All right. Go ahead and try number 13. Number 16, construct the line that's perpendicular to line L through point B. All right, so the first step would be anchor at point B and then draw an arc from point B. So obviously I can't do that. I don't have a compass that I can use here. So I'm going to draw a circle instead that is centered at point B. Okay, that looks good. And I'm just going to erase it so it'll be an arc. And it's just like if I used a compass. After you do that, go ahead and mark the points of intersection. And we're going to draw 2 more arcs from those points of intersection. So again, I'm using a circle. Go past halfway. Make sure it's centered. I was not centered. Hold on, I can't see. Get closer. That was not a good idea in retrospect. Okay, that's better. Okay, and I'm going to duplicate that, do the same thing over here. Okay. All right, once I got that situated, it looks off, doesn't it? I'm going to draw a line through this intersection. These 2 intersections, I mean. Okay, hold on, let me scoot that over. There we go. So y'all see that? Boom. Oh, no. Go back. Try that again. Boom. Perpendicular. Now, the way I taught you guys was to use arcs, not circles. So this is probably how yours would look if you did it with arcs instead of circles. All right, go ahead and try number 15. All right, number 18, construct a perpendicular bisector. Perpendicular bisector just uses 2 circles or 2 arcs. This one uses 3. So here we go. I'm gonna start by drawing an arc from point G. Hold up, let's go gray. All right, an arc from point G like that. And I wanna make sure it is centered around point G. I really can't tell, not gonna lie to you. Oh, I need to use the ruler, hold on. Give me a moment. I just need to use the ruler to make sure it's straight. Oh, nice, it was. All right, let me see if this one's straight. Oh my goodness, I have a really good eye. Not to toot my own horn. All right, let's try H. Okay, let's see. All right, H. Let's try this one. Oh, Lord, help me. Help me, Father, I'm struggling. Okay, there we go. Man, y'all teacher got a good eye. I did that freehand. Don't play with me. Okay, so once you have your 2 arcs drawn, or circles in this case, because I went ahead and had to do circles, you're going to draw a line. Now, I'm not going to be able to freehand this. I'm going to have to just bear with me, y'all. Bear with me. Hold up. There we go. A little bit lower on this side. There it is. A little bit higher on this side. There it is. All right, beautiful. Cool. And so that's it. That's my perpendicular bisector. It goes through the middle of GH, and it's perpendicular. Perpendicular bisector. I'm gonna erase the rest of these circles if you want to see what it looks like as just arcs instead of full circles. Beautimous. Beautimous. All right. Try number 17, but this is not right. Go ahead and draw a segment. Oh, just draw a segment and okay. Put 2 endpoints on it and do it like that. Okay, we'll call this AB, sure. But yeah, that one doesn't make sense because of the X. All right, don't forget to study. Obviously, I did the evens, and I want you to try the odds on your own to get practice. It is very important that you practice so that you can get better and learn. You're not going to learn if you just follow along with me and you never try it on your own. Thank you. Bye.